Hi, I'm Marc,
I'm Daniel Mesco.
and this is our program that we made with math classes. All right, so right here we have the two math classes, the angle inside and two sides, and then this is our main.
What does this program do?
It solves triangles with information you give it, if it has enough to finish the whole triangle.
Okay.
Right triangles, that is.
Do you want to show the program first or the code?
Show us what the program does, and then we'll talk about the code.
Chosen one is the main. We gave it a comical name because it controls everybody.
Okay.
I want to point out a little issue that I just noticed. Well, I noticed like a few minutes before doing the presentation. It's a right triangle. I knew you guys would notice if I didn't say it, so I made sure that I was going to say it. In a right triangle, angle 3, which is opposite the hypotenuse, will always be 90 degrees.
Yeah.
So it's just a little unnecessary extra line there.
So really, we didn't really need this.
So we didn't need the enter angle 3. But I just want to let you know because I figured that would come up in a question and I'd look stupid if I didn't know how to answer.
Yeah.
Yeah, so angle 3 is like 90, right?
It's always 90.
Yeah, it's always
in a
90.
right triangle. So, but anyway, go ahead and show
Alright,
some options.
So first off, we used J panel and J frame to do it instead of doing it in like a terminal. And what should we put in first?
Try two sides.
Just like 3, 4.
Yeah, 3, 4. We'll do a 3, 4, 5, and then you have to type in 0 for all the other values so that the string has some information in it, but it'll come out as a regular value. So it's a 3, 4, 5 triangle, and it knows the hypotenuse is 5, and it gives you angle 1 would be opposite side 1, and angle 2 opposite side 2, and it gives you the degree measures, which if you think 36, 53 with some change, it'll add up to 90, and then the other angle is 90. You can try.
Right.
Now you can try entering 4, 5 for side 2 and hypotenuse, and 0 for the side 1, or any combination of the
Yeah,
two
take out
sides.
that 4 and put a 5 on the hypotenuse and see what happens.
Yeah.
So like this and then 0.
Yeah.
Try that. So that's a 4, 5, and it gives you
Side
side
one
1
is
is 3.
Okay.
And you can do the same for if you have side 1 in the hypotenuse, it'll know to give you side 2, and it'll give you the number. And it works for any triangle. 3, 4, 5 is just an easy one to see.
Yeah.
It's a perfect, what do they call it? I don't remember the name. But either way, it works
triangle.
perfectly.
Like
Yeah, something
Triple.
like that. Triple, yeah, there you go. That's right.
Pythagorean
Pythagorean triple.
triple.
There you go. You can also enter a side and its corresponding angle, and it'll calculate as well. So try side 2, 4, and any angle for number 2,
So
as
like
long
what
as
should I
it's
put
less
in?
than 90.
Let's put like 50.
Yeah, and then get rid of hypotenuse there.
Oh yeah.
Then if you click enter, it'll give you the information on that one, hypotenuse and adjacent. And you already have side 2, so it doesn't give you side 2. Side 2 would be 4. And then you can add that information in if you want to find the angles. And it'll work for any two corresponding sides. So 1 and angle 1, 2 and angle 2, and 3 and right if you did. Actually, that's right. You do need the angle 3 if it's not
Yeah.
a right triangle. But in this instance, it'd be a right triangle. But you
Yeah.
can make it work without it if you want. For if you just had the hypotenuse and the opposite angle, because hypotenuse would still be the hypotenuse
Right.
in a triangle. It's not a right triangle, so it would work for any combination.
So let's just look at the
So
code.
yeah, we can look at the chosen one is the
Chosen one.
This is the one where it runs like all the main stuff. We have our imports. We just put java_x.swing with a little asterisk just to include everything. And then for the other stuff, we included like the action listener and action event to like have it know what to do with the buttons. And then you got the grid bag layout constraints that Foster taught us about where like everything goes inside the J-frame. Then we have like all of our stuff. We space it out a little to keep it organized. We got like private, all this stuff. And then we did private like text field 1, which is like what they put in.
corresponds with side 1 and
Yeah, and how this one corresponds with these.
the angles.
And then the side A and side B, we'll get to that later.
We use the
Yeah, it's at the bottom. That's also at the
and the
bottom.
doubles are at the bottom.
Right. Want to talk about this first?
So yeah, our constructor there, we name it with program, I guess.
I guess.
I don't remember that, but anyway, and then it goes to the init void down here.
Why do you call on super program?
Well, program is the title that it's given. Super means that it gives it to the title of the window that appears.
Okay.
It's
Give it
titled
top.
program. It could be anything. You could put in whatever title you
Yeah, I
want.
can't remember.
Triangles,
I
right?
can't remember what we put program.
Yeah, I don't know. But and then frame pack and set visible to true makes the frame visible. So it appears in front of you, and then frame pack just fits it all together.
So that,
Puts it
that's
so you
your
don't have to line it
constructor.
yourself.
There's
Yeah,
your
Yeah,
that's the constructor.
Yeah.
And then in the init void, we define some of the variables we declared up top. So there'd be a new J frame called frame, which is the frame itself, and there's only one panel. It's just a small frame. So it's called, and then we use grid bag layout for the for arranging it. And then there's only one button, which is the enter button, which is why we called it, or it's called button, but we gave it the name enter. And then 6 text fields for all of the for all the numbers, and the five in the argument is the size of the text field.
Yeah, it's like how many characters you.
I mean, yeah, so we just, but they're not gonna have that much to fit in there, so it's just numbers. And then title, we label it triangle. That's the title of the label, and the 3 sides. Now this is the label that. See, we said when it says set, I'll underline it. This means that we're gonna create a kind of a text that we can put onto the J-frame.
Yeah.
And then side 1 set label means it'll combine it'll put the text field right next to the side 1, so it kind of describes what is in it. So text field 1 is being described by side 1, which is enter side 1. Side 1 is the name of it, is what it is. So it's just you just type in the first side. And it goes for the same way for number 2 and number 3, which will be number 3 is actually the hypotenuse. So we just wrote that it's easier to write hypotenuse.
Mm-hmm.
And that's same thing with the angles. Okay, scroll on. You can go ahead and explain the layout here. I guess.
Like the angles? Like how is this the same
Well,
thing?
the gridding, yeah. Or the angles too, yeah.
Alright, I'll start with the angles. Like the same thing up here how we had. It's not like it's like a text field kind of, like where it says like enter here and then we have the text box.
You can pull it up on the side. You want us to pull it? We can, pull it up on the side so that we can kind of explain it as we go there.
Like right here, how it says like enter angle 1. It's not like, it's kind of like right here. It's like on top of the J-frame and everything.
Mm-hmm.
Same thing with like side 1, side 2, enter hypotenuse.
They correspond with the text field and the number of the text field is important because it determines how we interpret the input you give us.
Yeah.
And how it affects the triangle's dimensions.
And I'll just talk about down here, like where everything goes. So I like spaced out here. This is where like all the stuff that corresponds with.
Yeah, this is kind of laying
these
it out on
3.
an x and y axis, sort of.
Yeah, it's like an x and y axis. It starts up here at 0, and then 2 for side 1. So it starts like all the way over here, then down 2, down 3 for side 2.
Yeah, you can see the number goes down 1 correspondingly as it goes from 1 to the next to that. Well, it's not working, but 1 to the next. You see what I mean? And the same with the text fields. The text fields are moved out on the x value, but they stay the same on the y value.
Yeah, that's for the text. And then same thing for the angles. Alright, I don't know where it went.
Oh,
Down
there
there.
it is.
Same thing with the angles, how it started all the way to the left with 0, and then it started down from, this one ended at 4, this one's at 5 now, so it starts here and comes down, text fields right next to it. And at the button,
Button at the bottom, yeah.
and button at the bottom, which is right here, we started all the way over 3, which was like right around here, because text field is at 2, which starts here, and then all the way at the bottom, which is 8.
And then
Yeah.
frame.add panel means we just defined everything that's in the panel. We're saying panel.add means that we want to add all these contents to the panel at these certain dimensions, and then frame.add means we're going to add that panel to the frame. So otherwise, because it wouldn't really matter for us because it's just one panel.
Right.
But if you had multiple panels in a frame, you need to add all of them. So you can lay them out separately so that once it comes together, it lines up perfectly. But it's a simple little window, so it's only one panel.
Okay.
Alright, now this is where the good stuff is. This is all the action performs. This is what happens when you click the button. This is a long piece of code, but it's basically when you click this button.
Yeah, talk about action perform, action event E. What does that do? And what's going on with E inside this particular method, right?
With E. Well, what this void is it's a void that only is called
You
upon.
have an object E, right, of type action event.
Yeah.
Okay, you're passing that as a parameter to this method, action perform.
Uh-huh.
Yeah.
What is E doing? What does E do?
Let me see.
Anybody?
I mean, it's
Foster?
basically what you're explaining. It's like something that happens that the button tool is for. I mean, it's an action event. It's just a data. That's the data type of it. But basically, it is used within the program when you use e.getSource to say to basically have the if statement listening for an action event of type. Well, an action event that you define called E, and when it gets the source, it can figure out what the information is being sent to that event. So it's going to be like the button. Or whatever.
So E is the listening for. Well, I wouldn't say listening implies meaning waiting for a click on enter.
Right,
So
right.
E.getSource would mean when button is clicked, and would be equals button,
Yeah.
or it could be whatever button you have. So if you have multiple buttons, you'd have multiple of these if statements
More,
depending on what
yeah.
happens for each button.
Right.
And then within, since we're using numbers and not strings, we need to parse the number into a double. So
Right.
here side A equals text field 1 is assigning side A, a variable that we declared at the top, which is the ones we were mentioning.
Yeah, that we're gonna get to.
But right, side A, side B, side C, angle A, B, and C,
Yeah.
they're being stored as strings. So what you need to
Strings.
do
You need
is
to parse it into a double to do math
Right.
with it. Yeah.
right. Assuming the person truly enters what appears to be a double.
Yeah, we
Yeah.
hope it.
What happens
Go ahead.
if they don't enter a number? Run the program. See what happens if they don't enter a number.
I'm guessing we'll probably get an
Probably an
error.
error.
Like enter the letter. Yeah.
And just put like 0, 0, 0.
Let's see what happens.
It'll do something.
Oh,
Oh,
yeah,
yep,
yeah.
arrow.
We have backups if it's a number that, if we don't have enough information. Try just putting in one side, Mark.
Just one side?
Yeah, just one
And
side.
then what do I do with these? Just put them.
Zero for everything else.
Alright.
If you don't put in enough information, well, you gotta put an actual number in for side
Oh yeah.
one.
Whoops.
If you
I didn't see that.
See there, it'll give you the triangle. It can't be solved because only one side. You don't know. It could be an infinite number of possibilities for the other sides.
What if you fill in everything except for angle 3? Since you said it was always equal to 90.
Oh well, it'll use. I think whichever the first one it calls upon. So it'll probably. Which one do I call upon first? The one with two angles? Or no, yeah, the one with two sides. So it'll just do the two sides. It can go either way. Either one will work. It'll give you the information. But since I use two sides first, it'll probably give it the two sides one. And it'll just do the math with it. Because it only needs the two sides. It'll consider the extra information probably extraneous.
Alright.
And it'll probably give it to you again because it'll get there the same way. So then what angle C equals text field means that whatever input is put into the text field will be assigned to that string, which is why you need to add a 0.
Yeah.
Because otherwise you'll have a string with no value
Right.
in the program, and that'll
Yeah, we
cause
first tried to get it where you didn't have to enter 0, but we couldn't figure that part out, so we just had to have them, whatever you're not using, put in 0, the rest of the code, in order to get the work. And then we had to parse it after we stored them, turn them into doubles, and this is where we called upon our classes that we made. One called, was it two sides and then angles,
angle inside.
angle inside.
Yeah, angle
So
inside.
show the class, or should I just finish the if statements? They're basically like,
Well, yeah,
if-
go through this first.
alright, so it's like if they don't enter 0, blah, 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 blah. Then it
See,
goes
yeah,
on.
this is if it does. The doubles are initialized at 0.0, and even if not, you've typed in 0. So anything. This isn't in the instance that side 1 and side 2 are not equal to 0. Then it will
In
go
other
to
words,
sides now.
right. In other words, if there's something there,
Yeah,
if
two
it's
types
not
of
0, it's like 3 or
Yeah.
4.
whatever the numbers are.
Yeah, and then we had to open up in a option pane to show, like, this is the hypotenuse equals, and then we call upon our classes, the angle equals that. And then basically goes on within this giant if statement with lots of else ifs. And it goes on, this one's like if
If you have side 2 and the hypotenuse and all. Well, go for a minute. This is the 3 different types of triangles you can have here. Right here, 2 sides is the name of the class, and one's called hypot, side 2 and side 1, meaning which information you have. So hypot would mean you're trying to find the hypot, or the hypotenuse. Side 2, look at me. Side 2, you're trying to find side 2. Side 1, you're trying to find side 1. And the arguments here that you'll see in when we show you the class is the 2 sides. So integer 1 and integer 2 would be side 1 and side 2, 1 and 3, and 2 and 3. These are the 3 types of combinations of integers, or of information you can have given.
right.
So those are 3 different triangles, per perspective triangles you can see. Which is why we call upon hypot here, side 2 down there, side 1 down there.
and it's basically, this is if they don't really put
And
in
this is for
anything.
angles, yeah. 'Cause
Yeah.
5 would be angle 2. So this is if you have an angle and a side, which would call upon the angle and side class. And it also uses 2 arguments, but this time it's a side and an angle rather than a side and a side. And then here's a certain, well, I'll show you these functions, or these methods inside of that class. You can find the hypotenuse with the opposite, the adjacent with the opposite, all that type
Yeah, I'll
of
show the
stuff.
class. I'll start with yours, this one you made.
Okay. Public class angle and side is the one that calculates the triangle given an angle and its opposite side. So the constructor right off the bat starts with a side and an angle, and it declares them angle and side. Easiest way to understand it. The only difference is the side can be a hypotenuse, can be or 2 legs, or one of the legs. So the math you do within each method has to be different. So I've got 6 methods. The first one is find hypotenuse with opposite. which is, the name is exactly what it does. If you have the opposite, it'll find the hypotenuse. You have the opposite and its angle. And I was there on a piece of paper drawing out, these are quadrant 1 triangles, so I was out there drawing it to figure, because it was confusing me. But first you have to convert to radians. That's what this math.2 radians is, because the math operand needs to operate in radians. And we're asking for degrees, because it's the simpler way of understanding
Yeah,
angles.
people don't like to give you, instead of 180 degrees, you don't see people saying, okay, that's pi radians.
Yeah, that's
'cause it's
They
easier if we
prefer
just
to
do
give you
degrees.
degrees.
degrees. So it converts right over that.
It's not like, going from miles to kilometers. No, it's
Yeah.
a lot more,
And even if you multiply out pi, the real number would be, it's like you get some long decimal that nobody would remember for a 90-degree angle, something pi,
yeah, pi over 2 or whatever.
and then multiplying them into the math. So it's easier. So right off the bat we made a double called angle radians, which is the new angle converted into radians, and then the math is simple. Hypotenuse. This is if you do the trigonometric functions and you solve for the hypotenuse. So I skipped a few steps there, just solving for the hypotenuse. It's side divided by the sine, or side would be in this case the opposite. So if you do sine of the angle is the opposite of the hypotenuse, and then you would multiply by the hypotenuse on the bottom and divide by the sine.
How are you getting that side? Where are you getting that from in that method?
Side is it was your value
Yeah.
that you put in.
Oh, okay,
Yeah.
I see.
So side, and then returns the hypotenuse. The same thing for finding the adjacent with the opposite, but this time you have to use the tangent
Right,
function.
okay.
And it goes on that way for all of them. Hypotenuse with adjacent. These are all the 6 possible options. You can scroll down. They work in the same way. Converting to radians, doing the math. Here I have to multiply by the math tangent, because this time the one on the top is the information I don't have, and the one on if you're looking at a trigonometric ratio. So I've just skipped a few steps in doing the math to simplify the code. And is there anything left? That's it.
No,
So that's all of them. And it just returns the value of that side. So here it returns opposite because the function finds the opposite back in there, and then it gives you that information. So each triangle does 2 of these at a time. So if you give the opposite, or if you give the adjacent, it'll do 2 different methods to find the hypotenuse and the opposite. So you'll have all 3 sides solved by the end of just typing in those 2 numbers.
Yeah. Then we got this other class with only if they put in 2 sides, it can show all the information. So we got double side 1 and side 2, and then you convert them. This one is to find the hypotenuse with the first 2 sides, which was pretty easy. It's just a squared plus b squared equals c squared. So I just had to square them each, and then I did another double called find the hypotenuse, which took this value and then it divided by
You just take the square root
root of it and returned it. This one was find the side, which was so you added some touch-ups.
Yeah, this is if you
Yeah.
have this. This is if you're trying to find the side, but you have the hypotenuse. Because there's 2 different types of instances you can have. One is where you don't have the hypotenuse, and all you have to do is side 1 plus side 2. Side 1 squared, side 2 squared, and then take the square root of the hypotenuse. But if you, in the event that you have the hypotenuse and you're missing a side, you have to move over that a squared. So you have c squared minus a squared equals b squared if you're trying to find b.
Right.
So then this is a big, if you look at the kind of math, it would be square root of c squared minus, let's say, b squared, if you're trying to find a squared. And then, you don't need the square here, because you've just square rooted it. So you're trying to find a, that's what you, yeah. So first you do, the first math power is the big square root,
Right.
and then in the side of it, you've got the side 2 squared and the side 1 squared, and then the whole thing is to the 1/2 power.
I like the way you describe the formula by using the methods of the math class.
Oh yeah.
Yeah.
That's something that, most likely you're gonna do you're using Java. If you wanna do math at the pre-calc or the calc level, you're gonna have to do nested Powell methods and things like that. So I'm glad you guys did that.
Alright, then we had to do this one down here was find one angle with the 2 sides, which you use tan, and then, where was that?
A-tan
Yeah,
is
A-tan,
something I
that's what
looked
I'm
at, it's
talking
the
about.
inverse tangent.
Yeah, find the
It's the
inverse.
angle whose tangent
Is this- yeah,
is the
is that
argument
number.
of
Yeah.
that method, yeah.
Because I was explaining, it's like a new thing you taught me today before you presented, was the A-tan, which
The
finds
A-tan,
the inverse.
alright.
Not to be confused with the inverse tangent is different than
Yeah.
tan to the -1, which is, the reciprocal of the tangent is the cotangent.
Cotangent.
Yeah, inverse tangent is not the same as cotangent,
Yeah.
so,
Yeah.
And then you have to convert it to degrees because the information you get is in radians.
Correct.
Same
Side
thing.
1 divided by side 2, and then that. Then
And it's the
find
same thing for angle 2.
angle 2.
The x is just a way of kind of simplifying. You're still finding angle 2. It's just in this instance you have different sides. So there's 6 different options for this as well because you can find angle 1 and angle 2 if you just have 2 legs. And you can find angle 1 and angle 2 if you have hypotenuse and side 2 and hypotenuse and side 1.
right.
So each of them is a different way. It just uses, it's the same thing with the exception of this one being divided 2/1.
Yeah.
But just
Instead of 1/2.
with different functions, different
Yeah, yeah.
treatments, because the relationships are different between
Right.
the sides,
So 2x plus 1.
and that should be all the way down.
2xy. And yeah, then we do the sine, cosines, tan, side 1 divided by side 2. Still have changes to degrees like before. And then, yeah, it's pretty much
And
the
then it
same
returns the degree value.
Yeah.
Here, go back to the chosen one function, or the chosen one class. And then you can see side 2. This would be the triangle. Find angle 2x, and then in the J option pane, it puts out the information. So side 2 would be this, and angle 1 would be angle 1, and angle 2, which we declared up here, these doubles.
Yeah.
Right inside of the class. So it looks very clean when it's written out, but I had to sit there with triangles and we did lots of
Headers.
tests things. Yeah, because you've got to make sure that you're doing the right relationships because there's so many options for how the sides can relate to each other. You have to make sure you're choosing the right one, and that you have to make sure that people know that side 1 is here and side 2 is there versus the other way around.
Right.
But then once you have all that information, writing it down is just kind
Yeah.
of simple, just copy paste type of stuff.
Okay, very good. Put the output back there, if you don't mind, Mark.
This one?
Okay. Questions, comments? Foster?
Two comments. Okay, one, you should probably have like, just like probably one line of geometry pane before the program to tell the person using it that, you have to put in a 0.
Zeros,
Where you
yeah.
did. But to answer your problem with putting in like string or character stuff into the thing, I was trying to tell you earlier, I forgot how to do it. In the button, what you can do, if you go back to the main program right there, is this
Chosen one?
Yeah, chosen one. You go to your action event, E. Before you parse it into a double, but after you make it into a string, what you can do is that you can make everything after that code be all in one if statement that says, there's multiple ways to do it. See, like, if the number is going to say if it's like greater than or equal to 0 and if it's greater than or less than 0, multiple things like that to see if it actually exists in a number. That way, not only does that make sure your program only runs with numbers, but it also means that the button won't do anything if it doesn't have any numbers. It'll just run the if statement and nothing will happen. It'll just go back to the
So it won't crash like it did there.
yeah, it won't crash because it's basically the same thing. Basically just telling your program, look, you just make them a string. That's all you're gonna do, and then just go back to the program.
No, it's not
So
true.
yeah, I mean, sometimes you have to do that with buttons when you're trying to do error catching. You have to have it like the very beginning of the button because you can't have it obviously. Same reason why you can't get strings while in the program because it's still being created. But like the very beginning of a button, that's usually the best time to be checking for errors or like incorrect data types and that stuff.
Yeah. Well, what we had tried originally that didn't end up working is we had tried inserting right here
Yeah. It was a good
6 if statements that said if side A is equal to just quote or null, or we tried different values that we could use, then make the string equal to 0, and
Yeah,
just
we-
forget about it because we wouldn't need
Yeah,
it
so we
to
tried.
0. But it still didn't get
Yeah,
us there.
it's weird. I think you'd have to figure out a way to check not like if it's not check if it is a string and then not do something. We should have a check where check if it is a double or have any way of checking if it's a number, then use it run the program. I mean, you can look online. There's some really weird ways to
look
do
at
it.
it,
But I mean, yeah, I don't think it would work to try to see if it's, if there's nothing there, or if there's not anything there, you know, I don't know how to describe it, but.
Yeah, no, I got
It's kind of, I think the program's just getting confused on what you're trying to
it's
want to
trying.
actually. But yeah, I actually really like the program.
Thank you.
Intuitive, especially the math stuff.
One of the nice things about this program is you were so familiar with the trigonometry behind this program that I think you're explaining the code went more smoothly.
Mhm.
And that's one of the, in other words, the point I'm trying to make, guys, is get to know the reason why you're programming in the first place before you actually do the program. It goes back to making sure that you understand the pseudocode before you actually do this. I've noticed that sometimes people are given a challenge or they're given a problem and they try to come up with the code right away. No. Do a flow chart, do some pseudocode, do research about what
Triangles.
this should do before, okay? In your case, the past experience on geometry and trigonometry is what helped, what helped really to make this program be more, output more smoothly, right? The only obstacle that you encountered from what I observed was the issue with frames and all that, but
Oh yeah, we were new to
Foster
it.
came to the rescue.
Foster rescued us
Yeah.
there. Yeah, we figured
Okay.
we'd try something new this time.
First do
So.
a terminal, then we like, nah.
But I think we did a pretty good job.
Yeah, okay. Okay, thank you. Alt P, guys, Alt P.